today's problem from linear programming problem, and in this problem an incomplete simplex table is given, and which is also the intermediate table of simplex method. Okay, and in the first problem it is said that we have to complete the incomplete table, and in the second problem we have to determine the entering vector and departing vector, and in the third problem we have to write down the next table and show that the next table gives the unique optimal solution, which is given by x1 equal to 3 and x equal to 18. Okay, now we first complete the incomplete simplex table. It is clear from the first column, that is the column of CB. This is the cost vector of basis vector. Okay, this is cost coefficient, this is -4, so the first basis is A1 because the cost corresponding to A1 is -4. So we write here A1, okay, and -m, so the second basis is A6. We write here A6, and -2, that is the third basis is A2. Okay, and we write the corresponding variable, which are x1, which are x6, which are x3, right? And since A1 in the first basis, so the form of A1 is the standard basis of 3 dimension. This is the first standard basis 1 0 0. A6 in the second basis, so the form of A6 is 0 1 0, right? And A3 in the third basis, so it is, sorry, this is not A3, this is A2, so this is x2, and this is given by 0 0 1. This is the third basis, so we get the initial basis matrix 1 0 0 0 1 0 and 0 0 1. Okay, now net evaluation corresponding to this is given, and if there be a variable A we let, so from the calculation of Zj minus Cj, so Zj minus Cj, this is equal to -4 into -4 into -2 by 5 minus m into 1 by 5 minus 2 into A minus 0. This is Cj. This is given by minus m by 5 plus 6 by 5. Okay, and minus m by 5 cancel out, and this is 8 by 5 minus 2a, this is equal to 6 by 5. So we get 2a, this is equal to 2 by 5, that is a equal to 1 by 5. Okay, so we put here this is 1 by 5. Okay, and similarly this element, if it is taken to be b, then we get by the same calculation, this is -4 into 0, this is -m into -1, this is m, this is -2 into b, so -2b, and minus Cj is 0, so -0, this is equal to m, so we get this cancel out, so b, this is equal to 0. We put here 0. Okay, and another element, this is given by, let first, this is c, then by the calculation of this is -4 by 5, this is -2m by 5, and this is -2c is -0, obviously Cj equal to 0. This is given by -2m by 5 plus 2 by 5. 2m by 5 cancel out, and 2c is given by obviously -6 by 5, so this is c equal to -3 by 5. This is -3 by 5. Okay, now so we already done the first problem, complete the table. This is the complete table. We write the blank place in red color to understand better. Now it is clear that the most negative net evaluation, which is clearly -2m by 5 plus 2m, so this is entering vector, that is this vector enter in the basis. So our answer is the entering and departing vector. Entering vector is a5, right, a5. Now we have to find out the departing vector. To find out the departing vector, we have to draw another column. This is the mean ratio, column of mean ratio. Okay, and the column of mean ratio, which is given by 24 by 5 by 1 by 5, and this is given by 24. 18 by 5 by 2 by 5, this is given by 9, and since 63 by 5, this is negative element, so we cannot divide or we cannot find the mean ratio, and clearly this is the minimum of mean ratio. Okay, and this is the key row, and key column is also already find out a5, so our key element is 2 by 5. Okay, and clearly the vector in the key row, this is equal to a6, so a6 departing from the basis, so a6 is the departing vector. So our answer for departing vector is a6. Right, now we draw the second simplex table of this method. This is the next simplex table, and in the next simplex table we first fill the column of B, that is the basis column. Which are the basis column? A1 still in the basis, okay, and A2 is also in the basis, and in place of A6 we write A5, because A5 enter in the basis and A6 departing, so we write here A5, and we write the corresponding variable. This is x1, this is x5, this is x2, and the corresponding cost are given by -4. This is 0, because A5 corresponding cost is 0, and this is -2. Now we make the operation to key element transferred into 1. So it is clear that the operation for row 2 is given by row 2 dash, this is equal to, this is 5 by 2 into row 2. Okay, so this is, since this is 2 by 5, so we make the operation 5 by 2 into row 2, and this operation gives the result for the all the element of this row, and this is given by 9. Okay, and this is 0, this is 0, this is obviously 2, this is -2 by 5, and this is becomes 1, and this is 5 by 2. And since this is 1 by 5, so for the first row we make the operation R1 dash, this is equal to R1 minus 1 by 5 into R2 dash. Clear? Because this is 1 in the new R2, and so we have to zero this element, so we make the operation R1 minus 1 by 5 into R2 dash. And for the third row we make the operation R3 dash, this is equal to R3 plus 3 by 5 into R2 dash. Okay, because this is 1 in the new R2 and this is minus 3 by 5. And by the same operation we write here by calculating first and third row. We fill all the element of first row and third row by applying this and this operation, and here we leave left to calculate this column, because since this is the artificial vector and artificial vector here departing from the basis, so it cannot be entered again, so we can leave this vector as the blank vector. Okay, now we calculate the net evaluation Zj minus Cj. Clearly Zj minus Cj, this is equal to 0, 0, and here also 0, because these three are in the basis, and the net evaluation corresponding to this is given by, this is 2 and this is minus 1, so this is 1, and this is minus 8 by 25, and this is plus 12 by 25, so clearly this is 4 by 25. Okay, and we see that all of Zj minus Cj greater equal to 0. So condition of optimality satisfied. Okay, and in this case we calculate this cell also, and the calculation of this cell is as minus 4 into 3, that is minus 12, and minus 2 into 18, this is minus 36. So we get this is minus 48. This is the optimal value of the objective function. And so optimal solution is x1 this is equal to 3, x1 this is equal to 3, and x2 this is equal to 18, x2 this is equal to 18 with optimal value of z this is equal to minus 48. Okay, and since all the non-basic net evaluation, that is the net evaluation corresponding to H3 and net evaluation corresponding to A4 are non-negative, okay, this is are positive, so we say that this solution must be unique. Okay, we write here, since all non-basic net evaluation, that is Z3 minus Z3 minus C3, this is given by 1, and Z4 minus C4, this is given by 4 by 25, and these are greater than 0, so solution is unique. Okay, and this is the complete solution of this type of LPP problem. This is very important type of problem of LPP. Thank you for watching.